So my dear students, today's session start cutting tool materials, geometry and surface finish. So different types of cutting tool materials used to prepare the or to manufacturing the tool. And also the main important thing is the geometry of the cutting tool and the surface finish of the component. So these are the three important parameters you have to concentrate about the in this session or in this class. So before that, so you can detailed study. So the introduction of the machine tools. So introduction of the machine tools are four important points. The first point is machining of a metal involves coursing of the cutting tool through the excess material from the workpiece. Okay. Second important point, there are number of machining process available, variety of machining process according to the requirement. No single material is the best for every process. And third important point, in various machining process tool is very important, and hence the tool material is an important factor. It must be hard enough to sustain wear of the longer time. And fourth important point is after cutting the surface is observed on the product or component which is totally undesirable, then surface finishing after the cutting have much importance. So cutting tool material. So these are the four important points. So the metal cutting process involves the high local stresses, friction and considerable heat generation during the cutting. At the time of the cutting, the abrasive will be developed in the cutting tool and workpiece. The high speed machining, dry machining and continuous development for the machining tough workpiece material is extreme demands on the cutting force. So in this topic you can concentrate about that. Before that we have to study about the properties of the cutting tool material. It is very important. Cutting tool material, the types of cutting tool materials. Selection of the cutting tool materials is very important while manufacturing the tool. It is very important for cutting tool material. The material should be chosen, selecting such that it will be produces a certain job at a lowest cost. And third important point, that the cutting tool has to withstand the very high pressure as well as temperature during the cutting operation. At the time of the cutting operation, the withstanding the pressure as well as temperature is very important. The last important point is hence it must possess the number of critical properties required for the cutting operation. So there are various cutting tool materials having their own characteristics and applications. The cutting tool materials are, first one important point is carbon and medium alloy steel. HSS, second one is a HSS, that is a high speed steel. Third one is a cast cobalt alloys. Fourth one is a carbides. Next, fifth one is a coated tools. And sixth one is a ceramics tool. And BCBN, carbon boron nitride material, and diamond. So these are the 7 or 8 different types of materials used to cutting tool can manufacture. So as per your syllabus point of view, only you have to concentrate about the HSS tool, carbide tool, coated carbide tool and ceramic tools. 4 materials are very important and as per your syllabus clearly. So concentrate about the high speed steel material, carbide material, coated carbides and ceramic. These are very important, 4 important type of materials. So the characteristics of the cutting tool. So the characteristics of the cutting tool, the first one is a or properties of the cutting tool. Properties of the cutting tool material or characteristic of the cutting tool material. The important point is a hot hardness, hot hardness or red hardness. Both are same, hot hardness or red hardness. Second one is a wear resistance. Third one is a toughness and low coefficient of friction, low coefficient of friction and thermal conductivity and specific heat and chemical stability and inheritance and availability of the cost. So these are the 7 important points: properties of cutting tool material or characteristics of cutting tool material. Detailed study by one. What is the hot hardness? The hot hardness means the ability of the material to retain its hardness at high temperature. It is very, very important. The ability of the material to resist its hardness at high temperature is known as hot hardness or red hardness. Second point is can be increased by adding the molybdenum, tungsten and vanadium. Can be increased by adding mixing of that molybdenum percentage and tungsten percentage or vanadium percentage increase, then you definitely will get it ability of the material to retain hardness at the high temperature. Second important point is wear resistance. The ability to resist wear during the cutting operation, the tool is affected by abrasive action of the workpiece. And second important point, if it is wear resistance is low, there is a possibility of failure of tool. This leads to the poor surface finish. This is very important drawbacks. And third important properties or characteristics, toughness. Toughness, first important, ability to resist the shocks. At the time of the cutting, the shock will be developed to resist the shocks. Second important point, toughness and hardness should be kept in limit, as higher hardness material may cool brittle and weak in tension. And point, low coefficient of friction, the properties. To obtain the lower wear and better surface finish. Next, to obtain the lower wear in between the tool and work and the better surface finish. Coefficient of friction between the tool and workpiece should be as low as possible. In between the tool and the coefficient of workpiece should be as low as possible. And thermal conductivity and specific heat. In case of thermal conductivity and specific heat, it should have a high thermal conductivity at specific heat in order to absorb the heat generated at the cutting zone and conduct it to the. And last but one, chemical stability and hardness, inert. The chemical stability and inertness with respect to the workpiece material should be high, so that any adverse reaction contributed to the tool wear avoid. That's why it's very important properties or characteristics. And last one, availability of the cost. The material selected for the manufacturing, the cutting tool should be easily available in the market, and also important thing is a low cost. It is very, very important. So these are the 7 important different types of different properties of or characteristics of the cutting tool materials. Next, we'll go for the types of the tool material. Different materials used, any one, then you can manufacturing the tool. The first one is a carbon steel. Second one is a medium alloy steel material, and high-speed steel, satellites, cemented carbide, ceramics, diamonds, and abrasive. So using any one of them, totally 8 type of different materials so listed here. So in the syllabus, as per your syllabus point of view, only you have to concentrate about the HSS, high speed steel, and carbide, coated carbide, and ceramic. Clear, understand? So these are the different types of materials used to prepare or to manufacturing the cutting tool. Then you can detail steel carbon steel. So the types of tool material, carbon steel in that it contains 0.08 percentage to 1.5 percentage of carbon. Minimum and maximum range is given. So carbon in between these two values, low heat and low wear resistance. It losses their hardness is 200 centigrade to 250 centigrade. It is used in a tool operating at low cutting speed. Low cutting speed means it is at 12 meter per minute. And hand operated tools. The example you can take cutting player. That's it. They comparatively cheap, easy of forging, and simple to harden. So this is about the sorry carbon steel. So next you can go to the second one is medium and alloy steel. Types of tool materials. Medium and alloy steel. The first important point is high carbon medium alloy steel have carbon content plain carbon steel. In addition of 5% of alloy content consisting of suppose example you can take tungsten or molybdenum or chromium or vanadium. Only 5%. 95% is plain carbon steel you can use, and in addition of that 5% content consisting of the tungsten, molybdenum, chromium and vanadium. So third important point is hot hardness and wear resistance, shock and impact resistance, and resistance distortion during the heat treatment. Broadly occupy the midway performance position between the plain carbon and high speed steel. So next point is it lose their hardness 250 to 350 centigrade. Type is O or O oil quenched hardening. So the carbon percentage is 90, magnesium is 1, vanadium is 0.5, chromium percentage is 0.5. Type A are cooling in a current of air. Carbon content is 100%, chromium is 5%. So thread rolling dies and winding dies and gauges. So this is about discussing about the medium alloy steel. It is very important. So in case of a high speed steel, it is a HSS. Briefly it is written as a HSS, high speed steel. Generally the purpose of metal for the low and medium cutting speed, first stage is very important. It is owing the superior hot hardness and resistance to wear. Third one is it retains its hardness up to about the 900 centigrade. It is used for the popular operations drilling, tapping, hobbing and milling, turning and etc. Okay. So next point is molybdenum high speed steel. Generally it is molybdenum high speed steel means M series. Suppose cobalt high speed steel you can C series. There are categories. There are two categories. Suppose molybdenum high speed steel M series 2. That industrial technical term it is called as the M series tool. It is that indicates M series steel. You can indicate that the molybdenum high speed steel. So the molybdenum is 6%, tungsten 6%, chromium 4%, vanadium 2%. This is the standard value. It should not more than that. It should not less than that. In between that we can use that some percentage of the material. So molybdenum maintain neatness of the cutting edge. Vanadium have the excellent toughness of the cutting edge. Suppose example you can take the cobalt high speed steel C series, super high speed steel. So tungsten percentage is 20, chromium is 4, vanadium is 2, cobalt is 12. Sometimes cobalt is added from 2% to 15% to increase the high hardness and wear resistance. It is very important this one. Okay. So you can see that there are different types of tools in this HSS. It is made up of a HSS, high speed steel material. So this is a drill bit, milling cutter. Drill bit is a different diameter drill bit is available, and milling cutters are the different types of milling cutters, drill bits. Then single point cutting tool and multi point cutting tool. Different types of tools used to manufacturing using the material HSS, high speed steel material, to manufacturing the different tools. Next one is a satellites. It is a trade name of non-ferrous cast alloy. composed of cobalt, chromium and tungsten. Non-ferrous, that is very important. Satellite tool, it is a non-ferrous cast alloy composed of cobalt, chromium and tungsten. Range is 40 to 48 percentage of cobalt, 30 to 34 percentage of chromium and 12 to 9 percentage of tungsten, but non-ferrous cast alloy, the name, trade name. So carbon is added from 1.8 to 2.5%. They cannot be forced to sell. The preserves hardness up to the 1000 centigrade and can be operated on the steel at cutting speed is 2 times higher than the HSO2. Very important. Not used widely for fundamental cutting since they are very brittle. Not used widely for the metal cutting because of they are very brittle material. Used extensively in some non-metal cutting application such as rubbers and plastic cutting. Satellite tools used for the cutting of the rubbers and plastics. So you can see this is a satellite material used to prepare the tools. See, different types of tools material. Next is a cemented carbide tool. Next material. So they are composed principally of carbon mixed and other elements. Basic ingredients in tungsten carbide with extremely hard. Pure tungsten powder is mixed with cobalt until the mass entirely homogeneous. So next important point is this mixture pressed at a pressure of 1000 to 4200 kg per centimeter square into suitable block and heated in molybdenum hydrogen. Amount of body will regulate the toughness of the tool. So next point, important point is tungsten type of cemented carbide that's less brittle than the titanium tungsten. It contains 90 to 98% of tungsten and carbide is 2 to 8% of cobalt. It is used to machine brittle material. The main function it is used to use brittle material like cast iron, bronze and non-ferrous metal. Titanium tungsten carbide tools are most wear resistance. It contains 65 to 66 to 85% of tungsten, 5 to 30% of tungsten carbide and titanium carbide and 4 to 10% of copper. It is used to machine tougher material like various steel cutting. So you can see this is the different types of tools. These are the tool bits. These are the bits. Different tools are manufactured using the cemented carbide tools. Different types of tool materials, tools, different shape of the tool. Last but one, ceramic tool. Ceramic tool made from the ceramic material, capable of withstanding the high temperature without losing of hardness. The main concept. So these are the more wear resistance than cemented carbide tools. Not used for tough machining work because they are very hard or more brittle and have low bending resistance. Because of brittle material, low bending resistance. While machining with the ceramic tools, coolant is not required. Coolant is not required at the time of the cutting. They are made from the sintered aluminum oxide and various boron nitride powders. These powders are mixed together and sintered at a temperature 1700 centigrade, 1700 centigrade. Can be used at very high speed and produce a good surface finish. Brittle in nature, so they are used for the continuous cut. So this is about the ceramic material. So you can see that these are the different types of tools and tool bits. It is made up of a ceramic material. Diamond. Next is the different types of material. Diamond. So diamond is the hardest cutting tool and high wear resistance but low shock resistance due to brittleness. Low coefficient of friction, used to high grade superior friction. And next important point is used to single point cutting tool for light cuts and high speed. Next point, lowest thermal expansion, high heat conductivity and poor electric conductivity, brittle in nature. And last point, it gives good surface finish on the non-ferrous material, diamond tool. See that figure clearly, understand. It is made up of a diamond material at the edge of the cutting tool. So abrasive grain involve various like losses bonded into the wheel and stone, embedded the papers and cloths used for grinding harder material, and whereas a superior finish is desired on a hardened and uh, unhardened material. Aluminum oxide used for the high tensile material, silicon carbide used for the tensile material and non-ferrous metal. So you can see that it's the abrasive particles. You can different grinding wheels can manufacture here and different shape and size into grinding wheels. So it is a abrasive material bonded with a complete, it is a multi-point cutting. Grinding the wheel, it is made up of a abrasive, it is a multi-point cutting tool. Each board, this one abrasive particle, it acts as a cutting edge. So that's why it is called as a multi-point cutting tool. This is a grinding. So these are the important properties. You can see that is a different grinding wheels and sandpapers. You can see the papers, grinding different shape grind wheels and cutters. This is also grinding tool. This is also grinding wheel and different shapes. Depending on that, you can select that. You can very small amount of material remove from the workpiece. So point 25 to 0.5 mm material, that thin layer material removed from the component in the grinding process. Already we have studied in theory class. So this is a grinding process. Different types of tools, shapes, tools are used. So you can see this is a one type, second, third, so many types available in the market. Different types of grinding tool material. So you can see this. So, 2 point you can go for the cubic boron nitride (CBN), which is very important. Artificial material produced through laboratory using high pressure and temperature process. It's an artificial material. CBN is a hardness next to the diamond. Diamond is first. Next to the diamond, CBN is a cubic boron nitride is a CBN has a hardness next to the diamond. And important point is it is having a hardness, high thermal conductivity and tensile strength. And these tools are more expensive than the cemented carbide tools, expensive, costlier as compared to cemented carbide tools.